Howdy. I set up a HEC RAS 2D model using GIS data, survey data, and then a finished grade surface from Civil 3D. After importing it into HEC RAS, I ran a preliminary model and then I went through and added some culverts. This type of design can be really helpful when you have a rural road project with ditches and culverts to just see where your flow is going and check and see if your design makes sense. Thanks for checking out my video. Have a great day.
Today I'm going to show you how to set up a HEC-RAS file that's going to help you for rural road projects. Now there's several steps. The first one we want to do is grab some LiDAR. I'm going to go to Washington LiDAR portal. And once we get there, I'm going to zoom in to a project. It's a little bit difficult to see with all of the different data shown on here, so I'm going to hide everything. I'm going to go into the project, a project that I want to show you on. It's at 1/52 and 1/19. Now first I'm going to make a little box around this area, and this is the data sets that I can pull from. Now luckily recently there was a new data set that was installed, that was created for this area, so I'm going to download the digital terrain map from this area. Save it, see where it went. So downloading, extract this. So Clark County's data set is in the 1929-47 adjusted data set. This is a newer data set, which is in the 1988 data set. So I'm going to have to do a little bit of conversion. And then what I'm going to do is I'm going to bring this into a file and merge it with the existing surface and also with the proposed surface. So I'm going to basically overlay 3 surfaces on top of each other, and that is going to allow me to create a really good post-project surface or DTM that I can use in HEC RAS. Drop in my TIFF file, taking its sweet time. There we go. You can't see it because it's behind the ortho file, but here it is. And you can see I probably have more area than I actually need. This is quite a large TIFF file, so I don't actually want that entire thing. What I'm going to do is, first thing I need to do is adjust this data set by lowering it 3.28 feet. To do that, I'm going to type in raster calculator. Here it is. I'm going to bring in this value. I'm going to subtract minus 3.28 feet. I'm going to save this, just throw it on my desktop, call this 1/52, 2019, call this GIS 2019, and I'll call this 29 data.tiff. There we go. And I'm actually going to just pull in the extent, my view extent. To do that, I'm going to current display extent. So I'm going to sort of trim this raster, and I'm going to change the elevations all at the same time. Okay, here we go. Turn off this one. Here's my new one. You can see got clipped, and there's a good check. If I turn this on, explore, click right here. One of them's at 274, one's at 277. So here we go. It dropped to 3.28 feet, which is what we wanted to do. Turn this one off. Okay, next thing I'm going to do is another command. I'm going to turn this into contour data, which command called contour. I'm going to bring in my 29 adjusted data set. I'm going to make this a shapefile, also on my data set, 1/52. Contours shape, save, contour interval. I'm gonna do 1. You could probably get away with 2, but I'm gonna do 1. Max vertices per feature. I'm a little bit nervous about touching this, but this could be, I don't think I need to worry about that. Maybe a bigger data set, I might consider using that one. Okay, let's see. Oh, there's our contours. Okay, now got a lot of stuff on my desktop, a little bit dangerous. Open up a new data set. Little trick I can do, I'm gonna actually open up a project, open up the project, and then I'm going to create a new data set to work with my contour layer. Okay, so you want to create a new one. Okay, so I've got nothing in this file here. First thing I'm going to do is I am going to bring in an extra, and I'm going to bring in the line work to start. That will get me oriented. ZE for zoom extents. Next, I'm going to bring in my pipe network, which I don't have any yet. Bring in proposed storm. I'm going to bring in my surfaces. So the 2 that I really need existing, and I also need my top, which is my finished grade surface. So you might be thinking you already have a existing GIS merged. Well, the GIS data that was put in here is actually older GIS data. So if I did have that data set all set up, then I wouldn't even need to do this step. I'm showing you how to do this step. Okay, so next step, I want to make a surface with those contour data. So I'm going to go to Home, Surfaces, Create Surface from GIS Data. I'm going to call this 2019 GIS. I'm going to make this invisible. Next, shapefile. It's on my desktop right here. Login, click right here. I need to make sure that all looks good. Make sure I set contour to elevation and then finish. And there we go. Because you can't really see that layer, so I'm going to just show you just to make sure it's in here. Here we go. So here is my data set. So I'm going to hover a point right here and just show you. So you can see I have top, GIS, and existing. And existing and GIS are pretty close, but they're half a foot off. So I'm going to trust my survey data more than I'm going to trust the GIS data. The next thing I'm going to do is I'm going to merge those three surfaces together. So I'm going to make a new surface here called FG plus EG plus GIS. And I want to show this layer just for fun. Okay. So now I'm going to come in here and I'm going to, first, I'm going to paste the surface I want to be on the bottom. So the GIS on the bottom. Next, I'm going to paste the surface that's going to go on top of that existing surface. And that doesn't look that pretty, but kind of is what it is, I guess. And then I'm going to paste my finished grade surface on top of that. See, my ditches are all filled in now. Okay, the next step, okay, so this is kind of a good break here. So I basically have the surface that I want. I need to turn this into a digital elevation file or a TIFF or something I can bring into HEC-RAS. So to do that, I'm now going to right click on this, export to DEM, and that looks correct. DEM file name. I'm also going to bring this on my desktop. My desktop is getting full of stuff. This looks good. GeoTIFF save. I always like to change this to 99999. Not sure why. And I'm going to hit export. This might take a little while. You know what? While I'm doing that, I'm going to start setting up my HEC-RAS file. So HEC-RAS 5.07 is the latest and greatest. You know, this is going to be replaced very soon, actually, by HEC-RAS 5.1. I'm really curious when that is going to be happening. Not quite yet, but you know, I wouldn't be surprised if the next couple of weeks it's out. So first thing I'm going to do, I'm going to create a new HEC-RAS file. I'm going to call this 152nd demo, and where should I save this? Not to my desktop. You know what? I'm going to save this under trainings, hydraulics training. I'm going to make a new folder, call this 52nd demo, and I'm going to hit OK because I didn't put in a file name here. Now I'm actually going to go to that folder. I'm going to make a few more folders. So I learned from a very wise HEC-RAS person that it is very smart to have a set up your folder structure in such a way that you can find everything. So I just made this file here, but you know, I'm actually going to show you an example of what it should look like. RAS to north. Okay, so this is what I'm going to do. I want to basically get all these folders in here. So first one, aerial photos. This is sort of a thing of the past. I don't know. You really need aerial photos anymore, but you know what? I'm just going to keep the same folder structure as he had. Hydrology, land use. I don't have any, but I might someday start getting into that. I don't know what 5 is. Results. So 6, this is a folder I'm going to use a lot. The terrain. That's where I'm going to save my terrain file from my desktop. Shape files. Projection. You know what? While I'm at it, I'm going to grab the projection file and drop it right in here. So this projection file is basically a file that tells, it sort of like tells the data and the projection, you know, what sort of shape of the Earth are you assuming with this model, and where are you? Still working on this. Okay, so let's see what else we can do. Open up RAS Mapper is a good next step, and I can't bring in a terrain yet, but I can bring in my projection. And this is rect on projection, apply. Okay, so now it knows where I am, and it needs a terrain file. Now I'm going to cheat a little bit. I actually already created this projection file, or this terrain file, and I'm just going to copy it over because this is taking a little bit too long. Okay, so let's copy this over, TIR 60%. And I know right where to go because I have, there you go. This is the one I wanted. Okay. So now my folder has it. I'm going to bring in a new terrain. Actually, I said add existing. I want to add a new terrain. So if I already have an HDF file, I believe it's HDF. This setting is for if you have like a TIFF or DE. I'm going to bring in terrain file, and I'm going to save this as RAS. I'll just save it as the same name, and it's going to create a terrain file for me, which I believe is in this, yeah, you can see right here, HDF format, which is the format that RAS likes to work in. So if I already had an HDF file, I could use that. Okay, so we basically have enough to start setting up our file here. First thing I like to do is go into, I can double click on this, and I love turning on the update per screen. I think that just makes it really, really easy to see. I don't really know if I need those contours, but as I zoom in, and you can see there's this gray area here with no data, it's completely throwing off everything. But as I get past that, it's going to change everything to color. So as I zoom in, I can really kind of dial in what the grades are doing. Okay. So what was I trying to do with this data? Well, basically, I know that the outfall location is right over here, and I know that there is quite a large watershed coming in here. Water is going to be going along the ditch here. I can see a couple driveway culverts that need to get put in along here. And there's actually a couple roadway culverts that need to get put in here. So what I'm going to do right now is I'm first going to set up a very quick model. And to do that, I am going to just basically show you what to do to set up a quick 2D model. I'm going to add any geometry. I'm just going to call this geo. I'm going to add a 2D flow area. That's what I want to add. Perimeter, edit geometry. I'm going to basically just draw in a rather large 2D area that's just going to go around my entire project area. There we go. Call this BER for perimeter. Next thing I want to do, I'm actually going to make a refinement region because, oh, I'll show you how this works actually. Edit. Oops, click edit 2D area properties. And so this is how big the spacings of these cells are. I'm gonna make this smaller. I'm gonna generate computation points. So it generates all these different squares. Each square, there's only allowed to have one water surface elevation at that square. So, as water starts moving along here, so if it enters this tiny little square, it's also gonna be entering, it's also gonna be at that same water surface elevation at this square as well. And so that could or could not hurt you. If I had a big square that was all the way over this road, water would get into that square and then it would somehow magically make it to the other side of the road. So I want to have enough refinement that it doesn't do that, but I also, it takes more time to run a model that's bigger. One cool trick you can do, you can make the cell size a little bit coarser for the whole model, and you can make a refinement region is what I'm going to do here. I'm going to go in here, make a new refinement region, and this is going to be more around the actual project area that I kind of want to do. So I think I did 25 main project. I'm gonna make this 5. That seems pretty small, but you know what are you to do? And then I'm gonna enforce all region. That is not right. You can see everything became that. So let me go back to this. 25, generate computation. There we go. All right, so now we can see that might even be too small. Let's try 10. Again. That looks a little bit better. Okay, so now I basically have 2D flow arrows. Next thing I need to do is come in and create, well, there's a lot of stuff you could do here, but to make a course model, I'm going to set up boundary conditions. Boundary conditions are basically how you introduce flow or something exiting your site. So I'm going to introduce flow, create a new flow line right here. Actually, I'm going to cancel. I want it to be 2 points, so you kind of do boom. Call this, where's this, west flow. Next, could introduce some flow. You know what? I'm gonna Control Z that. I think it's preferable if you do it outside of your boundary. So we have an external boundary line, they call it. What I made before was an internal boundary line. West flow. I'm gonna introduce some here. Call that northwest flow. And I am going to make an internal, we'll do one more right here. We call this west northwest. Okay, next I'm going to make a new boundary line over here. I guess I should make it a little bit bigger, called exit. I think actually I probably need another one over here called exit north. Okay, that's actually quite a few boundary lines. I'm gonna save these, save this model, and boom. Next thing, still not done. Next thing I'm gonna do is I am going to go into geometry editor. So the geometry editor is basically like how you used to set up models, but the RAS mapper is sort of the new and expanded version. You still have to use geometry editor for some things, but it's really old and archaic. So I would not recommend using it. I'd use it for as little as you can, but there are more features in here, so you can do more in it. You can't Control Z, you can't undo in geometry editor. So take that for what it's worth. Next step, file, of a geometry data. So if you make a file, a geometry data file, this is going to look in your main project folder and see if there's anything. So we made one in the RAS mapper. When we saved it, it created a geometry file in that same folder. So I'm going to open that up right here. And you can see it has my boundary lines in here. You know what? I actually need to go back. I realized I didn't totally finish setting up what I wanted to do. So I'm going to go in here, layer, open attribute table. I want to make, oh, you know what? It automatically did it for me. External. Perfect. Sometimes you have to come in here and type in the right 2D areas, which remember we made one called BER for perimeter, and then external boundary type. I guess it just figured out what it was. I'm not used to that. You really shouldn't have both of those open at the same time, or at least I think RAS can get confused if you do. Okay, so that should be good. Save this. Next step is to create some flow. So we have all those boundary condition lines, right? So let's do the ones that are exiting first, because those ones are easiest. Boundary condition, so we call this normal depth, 105.05. What I do? Same for this one, normal depth, 0.05. Oops. Okay, so basically that's just telling it to maintain a certain depth. So it's not going to just build up as a giant wall. It's gonna exit at that normal depth. Okay, next I'm just gonna add in, I think, what should I do? 20 CFS for each of these. Sounds kind of good to me. I'm gonna do flow hydrograph. Oh, before I do this, let me back up a little bit. Actually, you know what? This should work. I'm gonna go to time 5, call this 20, 0, 0, and then you can do this little interpolate missing values, and it'll just kind of figure out the ones you're missing. If you can do a little, you can graph it as well, and that will, there you go, plot data. It kind of shows you peak, then it goes down. And I think you also need to do this. Also gonna make this 0.05 for energy grade slope. And I'm gonna literally just copy that exact same thing for all these. What did I do? 20 CFS. Electrical values, 0.05. Okay. 20 CFS, 0, 0. Okay. Here we go. I think that's all you need to do. Save this as 1/52nd blow. Okay. Next, I need to set up my model. To do that, I have a flow simulation. Flow simulation is basically telling you which geometry file to use, which flow file to use. So I might have 20 different flow files and 5 different geometry files, and I'm going to have what's called a plan. And the plan tells me which one to use. So I have been told previously to use 1, 2, and 4, so I'm going to do that. I'm just going to call this today, and today. I'm going to have this run for 0, 0, 0, and computation interval. I don't honestly know which one of these is the best, but more refinement is better, but takes longer to run. So you kind of just got to balance how long you have to run this model. It's not that big of a model, so I can make this thing go pretty refined. Okay, I think this should work. Let me save this plan. 1/52nd plan. Okay, I'm going to compute, see if it works. Oops, I did not type in the right number here. 24 hours. Let's try this again. I did make more cells than I did with my practice run, so this might take a little bit longer than I was thinking, but you know what? It's all about refinement and, high quality. Let's check on our other process, see how it's doing. It's getting closer. I mean, it's pushing 3/4 of the way there, and this one's taking longer than I thought. So I run this model pretty often, so I'm actually probably gonna go back to my cells and I'm gonna make less cells. Maybe I'll make my refinement region 15 or 20, and I'll make my main model 30, something like that, 30 by 30 cells. Because yeah, I mean, what are we at now? This is where I ain't got time for this. Well, what else can I do? Okay, well, here's something else I can do while I'm waiting for this. One other thing I need to do, and let me change my viewport here, is I need to bring in these culverts. So that's actually another step that I want to do. I also would like to bring in a few shape files as well. So I'll show you how to do that into my drawing. Actually, I'm going to start with a boundary shape file. And to do that, I am going to just click on my surface here. And I'm going to change the style to border only. And I don't see the edge of my surface. Must be right over top of this. Freeze a couple layers. You know what? Let me just freeze everything. I want to freeze my XREF layer. This must be it. Here we go. Border only. So I'm going to go up here, extract objects, and border. Okay, so now I have a polyline, a 3D polyline in the right spot. I probably go to, I could probably stand to weed this a little bit. It's got a few too many points on it. I don't know if I can weed yet. I can. It's not weeding as many as I thought I would. Maybe make this 5 degrees. There we go. Now we're talking. Okay, so it's pretty good. So I'm going to do something called map export, which is a command basically to turn stuff into GIS data onto my desktop, of course. I'm going to call this 1/52nd boundary. Click polygon. I actually need to select what I want. This one. And when you do polygons, you have to click this treat close polygons. Polygons as polygons. And I guess it didn't work. I think it's because it's a 3D polygon. I want to flatten this and see if that works. Still a 3D polygon. I can go to my modify, go to convert to 3D to 2D polygon. Okay, now I think I have my 3D polyline. I want to make this a different color just so I can see it better. And let's try that command again. Recent input, map export, 1/52nd bound. Try this again. One object selected, one filtered out. That is not what I was hoping for. You know what? I wonder if it's not closed. Is that possible? It's not closed. How did I know? One more time. 1/52nd boundary polygon. There we go. Okay. I don't know if you saw at the bottom. It said, I'll just show you one more time. It said, right now it says one object selected, one filter out, but when I change the polygon and I change this, so we want one object selected, 0 filtered out. That's what you kind of want. Okay. Oh, there we go. Finally finished. And this is still not done. Okay, well, we have enough to look at some data. So I can results, turn on my results, depth, and there we go, max. I can just kind of watch what happens. Here we go. Water's filling up. Fills up. It makes it over the top of my road. So let's slow down here. Pause. You can see, okay, water's coming in from here and here and here. So we want it starting to flow, and then it's trickling to here, and you can see right here it blows. Here's my road. You can, my model or my design is going to be very dependent on my road. But does water make it out of my model as I wanted it to? Playing with fire here over here without sorting my data very well. Starts disappearing. Ish. Playing with fire here without sorting my data very well, but you know. All right, so I just brought in that shape file, and you can kind of see it's sort of useful to turn it off if I want. I can change how it looks if I want. Struggling here to change how it looks, but change the line type if I want. You can do a lot of cool stuff, and this can be kind of a visual cue for you. If you want to look at it different ways, but I kind of find this helpful. Another kind of cool thing is if you're like, oh, how do I find that thing again? I'm lost. I can zoom to this layer. So, there's a couple cool things about it, especially if you have a large raster, really large raster, and you're trying to find where your road is. Oh, I didn't even show you this piece. You can also turn on web imagery. I like to do this a lot. Makes it easier to see. And you can turn it off or turn it on. You can click on here. I believe you can. I guess you can change the transparency so you can kind of see both, I guess, but I don't really need that right now. Okay. So I think this is looking pretty good. Okay, so I'm gonna save this. I'm gonna run this one more time, just to see how long it takes because I don't want to be running this forever. I have to run it a few times. And I'm gonna make this computation. Why don't I do this 30? You know what? 1 minute. What the heck? Hopefully this is faster this time. Boundary line was slow. Okay, I messed up my grid a little bit too much. It turns out. Fix another one. I'm gonna go put this one back to where it was before. Don't mess with it when it works. You're gonna break the model. There we go. And it's going a lot faster this time, which is really good. All right. I guess my model's not going to be quite as good, but I think it'll still be fine. Let's make sure it still kind of looks okay. Here it goes. Loads our road. Tries to leave the site. You know what actually I really want to do? I want water to be coming from either side of this road here. I think that would actually be really good. I'm not 100% sure the best way to do that. So first, I'm going to start with making my grid spacing. And then I'm going to make boundary condition. I'm going to make this right here. I'm going to make this one right here. Okay. See if that does anything different. And do I need a close RAS mapper every time I do this? I don't know. Sometimes I have to open it and reopen it, and my results, for some reason, don't show up when you don't do that. But I don't know. Play around with it. See what you find. Oh my gosh, that DEM finally finished. Cannot even believe it. This is perfect time to do my next step, which is adding in some culverts. All right, so I'm gonna have a few main culverts. One is from here. Actually, you know, I got a cool trick I can do. Sync pack 2 has something called pipes to poly. Add 2D polylines, layer 0. Okay, kind of cool. The thing is I don't need all of these. I just need some. So I'm gonna get rid of these. I'm gonna keep these. You can see it kind of shortens some. But yeah, I mean, it basically does some pretty cool stuff. Brings all the driveway culverts in just where you need them. All right, that is a lot of culverts. I'll start with a couple, and I'm not sure if I'm going to make it to every single one. But first thing I'm going to do is I'm going to just bring all these in as shape files. Map export. I want to make a new file. This one's going to be called culverts. Culverts. And polygon. Nope, line. 8 objects, 0 filtered out. 8 export. Okay, culverts. Here we go. Copy. Go over to, that's not what I wanted. It's the root folder. There we go. Okay, sheet files, culverts. Okay, let's go back to our restaurant and see if our flow looked a little bit better than we did before. Depth. There we go. You can kind of see it's struggling a little bit over here. I should probably make this bigger. You know what? I'm gonna do that. Keep fiddling with this thing, trying to make it better and better, but you know, can't help myself. Should never have changed it. It's working better before. Man, in reality, this boundary condition should really be over here. The road. Okay, you know, I probably should just be clicking force mesh recomputation instead of this other stuff, but you know what? Whatever. Okay, next step, I guess I'll just double check and make sure this works the way I want it to. Pretty quick. Try it again. Yeah, it's kind of struggling a little bit, you see. I think this water wants to go this way. I know there's a low spot in here, but all right, I'm not gonna worry too much about it right now. I was right to have this. Okay. Okay, I want to bring in those culverts, finally. And I can't see them too well, so let's change the color. How about this color? 7. Okay, now we can see these culverts pretty well. Right. There are some pretty cool ways you can import these, and maybe I'll show you a couple different ways to do this. I guess what I'll do here is this one's called 1. Okay, I'll just start with 1. So, open attribute table. Actually, go back to CAD, do map export. I'm gonna do another one of these. I'm gonna call this culvert 1. North, north, north. How about just super north? Pick a line. Okay. So my super north culvert, I just saved. I'm gonna bring in my super north culvert. And actually, what I'm gonna do is I'm gonna go to the regular geometry editor. So this is what I was saying. There's more tools in the regular geometry editor. First thing I'm going to do is I'm going to come in and I want to get to this lateral area 2D flow area connection centerline table, but I can't actually get there yet. So what I'm going to do is I'm going to just get kind of make one over here. And to do that, how did he do that again? 2D. All right, I need to cheat a little bit. Look at this. Okay, here we go. As he said, I'm going to enter 2D area connection. Call this here north, super north, right? Super north. Weir. You're like, what? What weir are you talking about? And actually, I think that weir should be right here. I'll copy these coordinates to the clipboard. These ones right here. And then I actually am going to go to my connection table. So this is the one I wanted to get to. I'm going to copy over here. I basically just moved that one I made right here. And then I'm going to import. I'm going to go to import barrel centerline and culvert 1 super. New barrel name was added. So you kind of have to have this, it has to go through this line, basically. Who knows why they set it up this way, but this is the way it's set up. Now I'm going to go to my 2D flow area connections. Oh, that's not what I wanted. I wanted 2D, this area connection. So you have to have a weir in here, unfortunately. And so I'm going to create a weir. It's going to be like barely over my road, so it's not going to do anything, and it's only going to be in this section, but technically you need something. So 052.26, I'm getting this number from right here. Elevation, I'm going to look at this, it's 280. I'm going to just call it 2, I think it has to be over the road, 280.1 and 280. Okay. So we got a weir going right over my road, you can see. Next, I'm going to go my culvert, and you can see that culvert that I put in is already in here. So I'm going to go 36.9, 36.9. I'm going to give this a 2-foot diameter, and you can see it's drawn right in there. It doesn't show up until I finish this step, but it will finish up. I'm just going to hit OK, and I guess I didn't quite finish 0.05. 0.5. Entrance loss, this actually should be 0.5. This should be 0.015 for Manning's end value. And then I need to get the elevations of this. So what I'm going to do to get that, so I'm going to draw, see, it's right in there, hold control, and go like this, cut profile. It's going to show me a couple elevations. So I'm going to grab 276.50, 276.20. Go back to my Culvert page, 276.50, 276.20. Okay, my Culvert on the map. Here we go. You can see it got drawn in right there. Okay, let's save this bad boy. I'm going to add one more culvert in, just a couple bigger ones, just so you can really see that I do something. There's a couple big boys right here, and one there. And, I don't actually need to import it from AutoCAD. I can just start right here. Here's my weir. Start with the weir. Copy coordinates. Go to connection. I'm going to add a new one. I'm going to call this south to north ditch. Got to highlight both. Copy. There you go. Now I have that in the way. Cut profile. So I'm kind of got it already. And I think I might need to cut a longer profile. I'll just put where I want my ditch to go. From here to there in the bottom. Pretty big ditch. Got my copy coordinates to clipboard. Let's go to my 2D area connection. I gotta put in a weir, but first I want to put in a culvert. And I guess I'll just call this barrel 1. Culvert length is, get that from right there, 118.39.55. And I have the depth already. Starts at 2. It has to be higher than the bottom, so just keep that in mind. It has to be higher than the LiDAR elevation. So you want to be slightly higher. 277.50, 272.50, 277.50, 272.50. Okay. I'll make this one 3 feet, 2 feet. I gotta put a weir in. 0, elevation 270, oops, 39.5, and get that from right there, 37.2. Okay. So got another one in there. And I want to make one more right from here to here. Make sure that makes sense. A little bit farther. I think that blue line might be my bottom of my culverts. Okay, that looks pretty good. So start with my weir. Copy coordinates to clipboard. And call this west to east main culvert. Make sure that makes some sense. Okay. Copy coordinates, go back to here. So I'll add in my weir to start this time. 0, elevation 279.50, 31.4, 280, I guess. And culvert lower length is 157.98. Loss 0.5, 15. Okay, upstream elevation. What do we get for that? 270, 250, 270, 250. And I'll make this one a little bigger for you. Okay. Bada bing, bada boom. There it is. Okay. Now this is where you pray, cross your fingers that it worked. All right. Run this back. Oh, great. Okay. I remember this is a sort of an error that it gives you. Okay. So when you bring it in as a shapefile, it doesn't give you this error, but when you draw it in like I did, it gives you this little error that you can fix pretty easily, but still slightly annoying. You just gotta set this. Well, this worked last time, so hopefully it works. There we go. Haven't got any fatal errors yet. That's a good sign. This is telling me that I created those weirs and, they're not working right, but, what do you expect? I basically am making a fake weir, so I wish there was a way you could do it without doing that. And maybe there is, I just haven't quite figured it out. All right, well, let's see. The model does seem to work, though. Zooming in the RAS mapper works so much better than it does in the geometry editor. Okay, let's see how we do. Look at this is coming into my culvert. Look at that. That's amazing. And you can see, wow, this is really, I think there needs to be a culvert right there. Anyways, you can kind of see water's coming in right there. You know what if I just move these boundary conditions? Well, doesn't really matter. Get the idea. So this culvert's not in yet, but I guess you don't really need it. Well, you know what? We're going to propose a driveway here, and we haven't done that yet, so that's why it looks fine. I think same with this one. Bruce hasn't put in the driveways yet, so my surface makes it look like there is no culvert needed. The ditch is continuous, but you can see water kind of moves along there. and I don't see water coming out the other side. I will say that these culvert lines aren't the same. I just kind of drew them in, so you might look like, oh, it's not coming out here, but I bet it is actually coming out down here. Actually, you know what? I have these cool little arrows. Let's see if it does anything for me. It does not appear that there's any mixing going on, but you can definitely see it's going in kind of stagnant water right here, and it's actually moving through here. And this whole area is flooding like crazy, which I think that just tells me this is like a wetland area. I think we need a culvert right here. You can see that, and that is blocking this whole thing. It does eventually make it over right here, but it backs up like a dam. Yeah, this actually works pretty well. I mean, no water's coming in here, and no water's coming in here, but that would be kind of interesting to see what happened as I move water. And I don't have a culvert here right now either, but I'm going to bring this culvert in and show you just how cool it is. Oh, you know, I'll show you a way I can do it. Make the polyline in RAS Mapper. So I can new layer, polyline, call this East Culverts, and I'm going to edit, and I'm going to stop it, and then I'm going to say export layer West Culvert. Okay. So now I will go into my geometry editor, hold Shift, pan, see pretty well. I'm going to make a line right here for my weir, copy coordinates to clipboard, culvert. There you go. You know what? This is where it gets cool. So I'm going to bring in culvert center lines, and if it goes through that thing, which it will, then right there, add it with the center line. So if this wasn't there, then it would give you an error. Okay, so now let me go to my west culvert. I am going to add my weir in 0, elevation 274, 10, maybe 20, and that is, I can kind of hover here, 276, we'll call it, 3217, 276. Okay, there's my little weir. Okay, culvert should already be in here. There it is, 2.9. Okay, so I gotta come in here now, and there we go. It's kind of interesting. Higher on this side than the other side. I'm just call 270, 270, 81, 271. Call it 2 feet, 270, 271. A little backwards culvert, but should do something. You can kind of see a little picture here. Okay, save geometry file, run. Start part of the connection. Same issue as I had before. Not sure why it does that, but slightly annoying. Okay, pretty much done. See what happens. There you go. Water makes it to the other side. It's amazing. And it still overflows. So, I mean, I got a lot of water running through here, so what do you expect? 60 CFS. I don't think this is really designed for that much water. But, you know, we're trying to test for flooding conditions, so this is what would happen. Okay, well, this has been a long video. I hope this has been helpful. I need to spend a long time and clean up my desktop because I got so much crap on it. All right, I will talk to you later. Have a good one.
Hey, thanks for checking out my video. Please check out any other videos I have and let me know what you think about all my content in the comments below. Have a great day.